where we should be today is we're in lesson 53. We're on page 349 in your textbook. Today's lesson is going to involve 45, 45, 90 right triangles. So before we get into drawing anything on the board, we want to read what it is that we have in our book. So there's actually two special right triangles. We're not covering both of them today. The other special right triangle is a 30, 60, 90 triangle, which if you're in some of the other classes, if you're in Algebra 2 or if you're in Algebra 3, this will be kind of old hat for you. Geometry splits these things up. In a couple lessons later, we'll get into the 30, 60, 90. The easier one of the two is the 45, 45, 90, because all 45, 45, 90 triangles are isosceles. All right, so the ratio is going to be really simple to remember. But before we hit any of that and start drawing pictures and working out problems, let's go ahead and get some information down. Brady, can you read that first paragraph on page 349? Yeah, new concepts.
Some right triangles are used to frequently, that is helpful to remember some of their particular properties. These triangles are called special right triangles. The two most common special right triangles are the 30, 60, 90 triangle and the 45, 45, 90 triangle.
Okay. Let's see. Eric, what does it say after that? Absolutely. Okay. Let's see, Matt, there's a nice little box underneath that. It talks about properties of a 45, 45, 90 triangle, side lengths. Can you read that for me?
In a 45, 45, 90 right triangle, both legs are congruent and the length of the hypotenuse is the length of the leg multiplied by 2.
Radical 2. Absolutely. Okay, so what we're going to do, you've read that. What you should do is you want to type that down, okay, or write it up in some form. Let's see if I can get my markers out here. If this will write for me. All right, so we're going to make an example here. Of course, I've got my right angle here. We can orient this in any number of different ways. Typically speaking, we're going to orient it this way right here. Okay, but you may see it oriented different ways. Okay, I'm going to make this a 45, 45, 90 right triangle. To make it clear for what we're going to talk about today, just so you know where we're at any given point, I'm going to label that A, B, and C so we know our sides that we're talking about and we know our angles that we're talking about. Now, one of the things we've covered a while back is the relationship of a side opposite of its angle. Okay, side opposite of its angle. So the side that's opposite this 45-degree angle here is that side right there. Okay, AC is opposite of angle B. Are we familiar with that up to this point? Okay, and I can see some heads bobbing up and down. So what is the side that's opposite angle C? What is the side that's opposite angle C? Brady? AB, so this side right here. And so these two sides, because they're opposite angles that are congruent to each other, then their side lengths are congruent. Okay, you follow me? Now, we always order these things from least to greatest. So 45, 45, 90 has this relationship. Now, if we were, later on, we're going to be using unit circle. Okay, and we do a lot of unit circle in Algebra 3 and even some unit circle in Algebra 2. And so if we based all of this, when I talk about unit circle, I mean basing everything around the number 1. Okay, which means to start with, to gain a basic understanding of the ratio, we would say, let's call our shortest side 1. Okay, well that would be here. Okay, and so if this is 1, what is this right over here? 1, right? Because they are, what's the mathematical term? They're congruent. Very good. All right, and that doesn't look very much like a 90, so let's do that. And so the relationship of 45 to 45 is a 1-to-1 relationship. Do we get that much? Okay, and then 90 is 1 radical 2. Okay, which means that the relationship of 45 to 90 is that length times radical 2. Okay, you with me so far? So if this is 1, then this is 1, then this is 1 radical 2. Okay, but we can work with all kinds of different numbers. It's not always going to be 1. And so I'm going to change up this a little bit here so that you can see it, how it would work just any time. Okay, if I can do that without erasing too much, is let's call this x. Okay? If I don't know what it is, and let's just call it x for now, if AC is x, then what is AB? What do you say, Matt? X. Okay? You're absolutely right. Okay, so if AC is x and AB is x, then what is BC? X radical 2. Okay? And this is maybe a better way to see it on a regular basis. Okay? Because if I know that the relationship is x radical 2, then I can start to put any number in for either AC or AB. For instance, somebody give me just a single digit number. 4. So let's say that AC is 4. Then what is AB? Okay, 4. Then what is BC? Now all I need to do is substitute the number that I'm given in for x. Is that works for us? So we could even take a double digit number, a triple digit number. You know, let's say this was 242. Then this is going to be, and this is going to be 242 radical 2. Okay, so we get that. Now we can make it a little bit more difficult. Let's add some difficulty to it. Let's say this one, let's flip this guy back over and make it just a standard 45, 45, 90. Let's make our life more difficult because sometimes our homework is more difficult. Let's say that this was radical 2. Okay, let's throw in a radical. What would this one be? That would be radical 2. Okay, what would this be? Radical 2 times radical 2, right? So I would write it up like this, but would that simplify? It would be 2, right? So notice that the hypotenuse could be a whole number, right? All right, let's make life even a little bit more difficult. Okay, again, because we won't be more equipped until we're able to handle questions that are more difficult than really just the easy basic things. Let's take this and let's make it 6, because we've done these before, right? If I start here, then I know this, then I know that. All right, let's start with this one here. Okay? What's more difficult about this is understanding that that if this is x, then this is x, then this is x radical 2, right? So this is equal to x radical 2. Do we get that? So let's take 6 and set it equal to x radical 2 and try to solve for x. How do I solve for x in that question? Divide by radical 2, okay, on both sides, right? Okay, so x radical 2 equals 6 over radical 2, correct? Okay, because I'm going to cancel that out. Okay, and so as I erase this, what I'm getting is that x equals 6 over radical 2. But can I leave it like that? What do I have to do? Multiply by radical 2 over radical 2. Okay? Because I need to rationalize the denominator. How many of us remember that we would need to do that? Okay? A small handful of us, which means if we didn't remember that we needed to do that, then we need to make a note. We need to write that down. All right, so as we look across the top here, what do I get whenever I take 6 times radical 2? 6 radical 2. Okay? Jesus is kind of carrying the class here. What's radical 2 times radical 2? 2. All right. Am I done here? No. Can that simplify? Yes. What is it? X equals 3 radical 2. So if it's 6, then this is 3 radical 2 here, correct? Then this is 3 radical 2. And I can check my work, right? Because we've got that as my answer, but that would mean that this is 3, clear that out. 3 radical 2 times radical 2, right? Radical 2 times radical 2 is 2. 3 times 2 is 6. All right, so I know that my answer is correct because whenever I plug it back in and test it, I get the hypotenuse that they told me I would get. Does that make sense? Okay, so do we have a pretty basic understanding of the 45, 45, 90? Right, because 30, 60, 90 is going to be a little bit tougher. If we don't understand 45, 45, 90, we're probably not going to understand 30, 60, 90 very well. Okay? All right. So I'm going to we're going to erase a whole bunch of this information. And we're going to start trying to answer some questions. Okay? All right, let's pull this guy up, and we want this guy. All right, let's look at some word problems. Okay, an architect designs the front view of a house. So we're looking at it. If we had to, we'd put a little door, little windows, and all that kind of stuff. We're looking at the front view of the house. And you'll see this question show up on a test. And I will say that this is one of the most missed questions on tests. No matter how many times I've covered this question, people continue to miss it, all right, because we're not looking at the details. All right, the roof that we have here is a 45, 45, 90 triangle. And I don't know if the reason that we struggle with it is because it's not oriented the way that we normally look at it, but the angle, the right angle, should go there, right? This would be my 45. This would be my other 45. And the reason I know that is because the opposite sides of these angles here and here are the same. Okay, do you follow me there? Okay? All right. The overhang, that's the important part. This is vitally important in understanding. Okay? This says that this is 16 meters. It's not 16 meters from point to point. It's 16 meters of the width of the house. That 16 is only going from here. Let me make sure that's clear. From here to here. That's the 16 meters. Okay? Do we understand that? It is not 16 meters all the way across. It's only 16 meters from the edge of the house to the other edge of the house. Okay? It has a ½ meter of overhang on either side. Okay? Past those red dots. Okay? What should the side lengths, these lengths right here, what should this length and this length be? Round your answer to the nearest meter. Okay? So what is the true hypotenuse of that triangle? Is it 16? It's 17 because there's 16 and ½ meter on either side. What's a ½ meter plus a ½ meter? 1 meter. 16 plus 1 is 17. All right, so let's erase this so that we can kind of see our question again. All right, what we're saying then is that from here to here, all the way across, is 17. Now, just like the question we covered before where I made the hypotenuse 6, right? What did we have to do with that 6? Divide by radical 2. What do I need to do with 17? Divide by radical 2. Because 17 equals x times radical 2. So I'm going to divide by radical 2 on both sides. I'm going to get 17 over radical 2 equals x, or in this case, L. What do I need to do with 17 over radical 2? Multiply it by radical 2 over radical 2. 17 over radical 2 times radical 2 over radical 2. What's 17 times radical 2? 17 radical 2. What's radical 2 times radical 2? 2. All right, so this would be my answer in radical form. Okay? Notice that they wanted our answer to the nearest meter, but I do want you to understand this. So all I need to do is take my calculator and take 17 divided by radical 2 and get a decimal answer. What is 17 divided by radical 2? Helps to have a graphing calculator or just a calculator that will do radicals. Okay, and it comes out to like 12.02, right? But because it says round our answer to the nearest meter, our answer is 12 meters. Okay? Go ahead and take 16 divided by radical 2. Let's see if that answer actually exists on the board. What's it come out to? What's that? 11.31, which you would round down to 11, right? So the wrong answer, right, or the right answer with the wrong work, right, is on the board. A good chunk of people, hopefully not most, but whenever you see this question on a test, I'm warning you that there's going to be a bunch of you that are going to pick A because you're going to do 16 and not 17. Be careful. Okay? All right, let's pull this down. This is a question that shows up on a number of tests. And this is, by all means, kind of a tougher question. Okay? What we are trying to solve for is X. Where we have to start from is all the way over here on this rightmost triangle. Okay? And so we're going to work our way across over to this guy over here. Now, we're going to keep in mind our ratios. Okay? I'm going to put a red dot everywhere where there's 45 degrees. Okay? Instead of trying to write in 45 degrees. Okay? This is 45 degrees. That's 45 degrees. This is 45 degrees. That's 45 degrees. This is 45 degrees, and that's 45 degrees. Because it says each triangle is a 45, 45, 90. Okay? So what we're going to do is we're going to fill in all the information for each triangle as we go. Okay? So if I know that this is 3 right here, can I tell what that is? What is it? 3. Okay? So far, so good. All right? What is the hypotenuse of this triangle? What is this right here? If this is 3, then this is 3, then my blue line is 3 radical 2. Correct? Okay, good. All right, keep in mind this is 45. What would this other blue line be then? 3 radical 2, because it's also opposite a 45 degree angle, and they're all 45, 45, 90s are isosceles, so in any 45, 45, 90, I should have 2 lengths that are the same. All right, now let's solve, let's see, let's come back to our red color here. What would that entire length, that entire red line, what would that entire red line be, or how would I find it? 3 radical 2 times radical 2, right? All right, well, what's radical 2 times radical 2? 2, so what I'm getting is 3 times 2, so that entire length is what? 6. That entire length here is 6. Okay, so what would be just the hypotenuse of that smallest triangle? It would have to be just 3. Okay, so now that I know the hypotenuse is 3, I just want, let's make him blue, I just want that side right there. What do I need to do with that 3? Because it's the hypotenuse is a whole number, take 3 and divide it by radical 2. Okay, well, can I leave it like that? Multiply by radical 2 over radical 2. So on the top I get 3 radical 2, and on the bottom, 2. So my final answer is 3 radical 2 over 2. And of course, this guy would also be 3 radical 2 over 2. Okay? And if I ended up multiplying it by radical 2, right, I would, in order to check and see if that 3 makes sense, I would take 3 radical 2 over 2. I would multiply it by radical 2. On the top, I would get 3 radical 2 times radical 2, right? That ended up being 6. 6 divided by 2 would be 3. I would get that green number again. So our answer is going to be that right there. Okay, but you notice that we had to start all the way at the right, work with the information that we had. Everything was 45, 45, 90. Was that question too difficult to solve? No. Okay, but again, it's a really tough question on a test because we've got to remember everything else. Okay? All right. Let's see if we can cover some others here. Hopefully this is a little bit easier. If this is 45 right here, what is this other angle? We know it's got to be 45. All right, find the perimeter. So let's just find the length of every side. Okay, what is this length right here? 6, good. Then what is this side right over here? 6 radical 2. So if I'm trying to find the perimeter, what do I need to do with my calculator? Add them all up. So what's 6 plus 6 plus 6 radical 2? right? This is where we get our calculators out, right? Because it's looking for the nearest hundredth, right? Hundredth is 2 decimal places. Hundredth is 2 decimal places. Sorry, what was that? 20.48. Let me double check. $20.49. We could agree with that. 20.49, oh, not feet, but inches. 20.49 inches. Do we feel pretty good about that? Okay. 20.49 inches is 6 plus 6 plus 6 radical 2. Okay. Let's look on down here. A square rug. A square rug. Okay. So we're going to draw a picture of a square. Now, what are the angle measures of a square all the way around? 90. Okay, 90, 90, 90, 90. And a square is a parallelogram. It is also a rhombus. And if you remember in a rhombus is diagonals bisect opposite angles. All right, what's half of 90? 45, which means this is now a 45, 90 triangle, right? Okay, because of diagonal cut across it. A square rug has a diagonal of 21 feet. What is the square footage of the rug? Which means I need to find this length and then multiply them by each other because we're looking for the area of the rug. What do I need to do with 21? Divide by radical 2. Okay, and because we're just looking for the square footage of the rug, we can just go ahead and find the decimal of that, right? Or we can multiply by radical 2 over radical 2. That's going to give me 21 radical 2 over 2, right? That's going to be one side length. 21 radical 2 over 2. If I want the area of a square, the area of a square is side squared, right? So all I need to do is take this and square it, right? What's 21 times 21? 441. Okay. What's radical 2 times radical 2? 2. And 2 times 2 is 4. So I would get 441 times 2 divided by 4. 441 times 2, I want to say 884, or 882. Am I wrong? It's 882. What's 882 divided by 4? 220. 220.5. 220.5 feet. Okay, let's see if I've got an answer to that question. 220.5 feet. What am I missing? Squared. 220.5 feet squared. And I think this is our last question. So let's see if we can get it done. We've only got a couple minutes. Find the exact length of the hypotenuse of a 45, 45, 90. If one leg measures 8, right? That's got to be a leg. So what is the hypotenuse? 8 radical what? 8 radical 2. And that is, whenever they say find the exact, that's how they want it. Exact always means in radical, simplified radical form. So 8 radical 2 is my final answer. You guys should know what your homework is. 8 radical 2, let's see, we need just one more thing here is centimeters. Okay, any questions about any of that? We're all done. I'm going to hit pause on that.